Hi, in this video, we're going to take a closer look at the concept of net present value. We'll explore what it is, how it is calculated in general, then we'll look at an example in Excel, and finally, I'll discuss some assumptions and limitations of the method. Let's get started with what is NPV. NPV, for the net present value method, is used to evaluate long-term capital projects or investments and assist management in the decision-making process when comparing different projects or investments. The NPV formula accounts for the time value of money by representing all future cash flows, whether they are inflows or outflows, into a single value. And this single value is what allows comparison between different projects. In addition to this facilitation of comparison, it also allows management to ascertain whether a project or investment will be profitable and therefore feasible given the particular financial position of a company. Let's break it down with an example. The ACM factory produces building materials to the construction industry. The business is currently in the market to invest in a new machine that will mold cement blocks. Through the use of innovative technology, ACM will be constructing a new type of block that are used in sustainable building projects. The internal research and development team, alongside with management, are faced with a decision that requires them to choose between two different machines. Either machine will require an initial investment of $3,000, and each machine is expected to generate a series of cash flows for a period of 3 years. At the end of the 3 years, the machine will be obsolete with no resale value. Due to its limited capital budget, ACM must select the machine which will result in the highest profitability. This is where the NPV calculation comes in. So before we jump in and go do this calculation in Excel, let's just take a closer look at the particular cash flows which apply for Project A. So in other words, Project A is what we want to evaluate. And then also at the same time, let's have a look at these different formulas for representing the net present value and how we would actually go about calculating the net present value. So we start off looking at the particular cash flows for Project A. And we notice at time t equals 0, we will have to make an investment, an initial investment of $3,000. Then at the end of year 1, year 2, and year 3, there will be 3 different cash flows: $3,250 first year, $250 second year, and $150 the third year. So how do we actually, we said NPV is this calculation, taking these expected future cash flows and representing it in single value. How do we do that? Quite simply, we do time value calculations. And in English, this is what the formula would read like. It would say the present value of the cash inflows, in other words, the 3,250, 250, and 150 in those different years, subtract from there the initial investment, which we know is 3,000. So we would need to calculate a present value for each one of these. That's year 1, that's year 2, year 3. And when we have this total, we would subtract the initial investment. And that value would give us the NPV. Let's actually have a look at how this formula is calculated or represented and calculated in most corporate finance handbooks. So now when we express this mathematically, we would say the summation from T equals N of CFT. In our example, this CFT evaluates to CF1, CF2, and CF3 with the particular values of $3,250, $250, and $150. And then the actual discounting we'll apply will be via this formula here, 1 plus the weighted average cost of capital, which is we represent with R because it's a rate, and 1 plus R, this rate, if we assume this rate to be 10%, then that would be 0.1 when we express it as a decimal value, and 1 plus R becomes 1 plus 0.1 to the power 1 when t, the first initial t, when it's 1. This will be 1 plus 0.1, which we know will be 1.1 to the power 2 in the case where t is 2. And here we will divide 1 plus 0.1 divided by to the power 3. That's how we do the discounting there. So we will add all of these values together. That's what we do with the summation here. N was 3 in this instance, when we're in the instance of project A, and we'll do this in Excel now. So this will give us a value, that will give us a value, that will give us a value. We add these up, subtract the initial investment of 3,000, and then we have our NPV value. I would like to also add just one more way of actually calculating this, which I haven't seen in books, but I think we can represent all of these different cash flows quite simply with just this formula, without saying now subtract initial investment, etc. We can express the initial investment also as a cash flow, right? So the difference here is that we're doing this from t equals 0. So t equals 0, and when it's a cash outflow, the initial investment, it'll be a negative value. So in this instance, we will have 4 cash flows, which will be CF0, in other words, at time 0, CF1 times 2, CF3 times 3. The values are respectively 3,000, 3250, 250, and $150. So this portion of the calculation will stay the same. There won't be any differences there. But when we look at this cash flow at initial time t0, when we discount this 1 plus 0.1 to the power 0, it's important to note, and let me use a different color here, that any value, when we raise any value x to the power 0, this becomes the value 1. If you're not sure why that is, have a look at this video. Okay, so this evaluates to 1. In other words, you will remain with minus 3,000 here, just through a use of a little bit smarter mathematics. But you need to be aware of the exponents, some of the exponent rules here. So now let's go to Excel and go perform these different calculations. Okay, here we are in Excel, and we are evaluating project A. We have these cash flows, the 3,000 initial investment, so in other words, minus 3,000, an outflow of cash, and then the associated inflows for year 1, 3,250, at the end of year 2, 250, and the year 3, $150. So those are T's, the T's 0 to 3, T to N, or from 0 to 3, that we saw in the previous section where we actually evaluated the formula. These are the different cash flows, minus 3,000, etc. So CF of T for each of these T's. And then what we need to do is calculate the sum, okay? And we have this, the weighted average cost of capital, which is a rate. I've just put it as WACC here, but it's actually R subscript WACC, or we could just say the rate. We're representing it with this, with the name WACC. Okay, and that's given as 10%. Now, let's do the actual discounting. We know when we discount minus 3,000 2 times 0, this will actually evaluate to minus 3,000. So we're not going to do the long formula here. We don't need to do that. We'll just, for now, put in it as minus 3,000. However, for the second cash flow and all the subsequent cash flows, we need to say the cash flow value and divide by, in brackets, 1 plus the, we're going to dollarize that, 1 plus the weighted average cost of capital, and then raise this to the power of t. And that means the second cash flow will be 2955, but we were being very smart here. We just dollarized the weighted average cost of capital in this cell here, the C7. The remainder, we should be able to now just drag them with this bottom right square, and this will calculate the values for us. So in other words, the second year, 250, when we discount this, it is the cash flow, which is found in cell B4, and we discount 1 plus C7, because it's dollarized, it's now a fixed reference, WACC being 10%, and raising that to the power T, which is A4. So it does the calculation for us. We're being a little bit smart there. Second, the third cash flow, the same thing. Cash flows in cell B5. The discounting rate of 10% remains the same as still C7, but then T now moves to the cell A5. So we have all of these cash flows here, and then the NPV is found by purely saying sum of all of these cash flows. So in other words, something that's important to note here is that we have positive and negative cash flows, right? Negative cash flows represented by negative values or outflows, and inflows are positive values. So that's where the net present value comes from. The net in the name, net present value, is because it's the net value once we've offset negative values from the positive inflows. So the sum of all these values return a NPV of $273.85. That is the NPV for Project A. We are now in a position to calculate the NPV for Project B, and then we'll do the comparison. But because the calculation is exactly the same, this part, the calculation of NPV in Excel of the next one, we can actually fast forward through. I'm not going to talk you through that. Let's just get to the value so we can get to the comparison component. All right, great stuff. We have now calculated two NPV values, each associated with a project. So for project A, we arrived at an NPV of $273.85. And for project B, $325.92. So this is what we meant earlier when we said the NPV compresses that data, represents the aggregate of all of these future cash flows into a single value that we can now compare. So we can do that. We have project A that we expect from those values, the expected forecasted cash flows, that it is worth $273 at present, and project B, $325. So clearly, project B, when using the NPV approach, is the superior project. This actually indicates to management that project B is the project that is expected to generate the highest profitability, and therefore the preferred course of action. Purchase project B if you have to choose between either of these two. What are some of the assumptions we made? Well, first of all, we assumed that ACM has limited capital available and that the company is required to apply capital rationing. In other words, it has to decide on which of the two machines or which of the two projects it wishes to purchase. A fundamental component of our method of calculation was the assumed cost of capital. In other words, the discounting rate, which we represented by R subscript WACC, the weighted average cost of capital. It represents an interest rate or a required return, rate of return. So it's a rate, that's why we're using R. This cost essentially forms a hurdle rate for the evaluation of projects. What that means is that if a project produces a negative NPV, it will not be profitable for ACM to tackle. It also means that if ACM had the funds available and there wasn't a scenario of capital rationing, it should accept all projects that produce a positive NPV, as these projects will add value to the firm. This is the hurdle rate effect. We have furthermore made simplifying assumptions in order to produce the NPV values. What were some of these assumptions? Well, for one, we assumed that each project or machine will produce cash flows at the end of the 3 years. These values are forecasts and often associated with specific economic conditions. Essentially, it's an educated guess. In other words, what growth do we expect to occur in the relevant industry in the future? And what do we expect the state of the economy to be at this particular point in time? This along with a multitude of different interdependent variables when we make these kind of forecasts. In the world of financial mathematics, we're not being very precise. And as long as we're consistent, then we can at least derive some value from these comparisons. In short, some assumptions we made were done to facilitate the ease of calculation. Although it is easy enough to extend the methods used and account for cash flows occurring in the middle of the year. We will, however, not be doing it here. So in this video, we assumed a company had limited capital funds available and were faced with a decision between competing projects. We then calculated the current or present value of these projects or investments in order to compare these projects or investments. And then preference were given to projects with relatively higher NPV values, and this allowed for ranking of projects to establish an order of preference. By discounting at the company's cost of capital, we were also able to highlight which projects would add value beyond the cost to the company.